This explosion was 261 quintillion times more luminous than the Sun, and 20 billion times more luminous than the entire Milky Way galaxy. This was GRB 221009A, the most powerful gamma-ray burst of observational history. Despite being around 2.4 billion light-years away, it was powerful enough to affect Earth's atmosphere, having the strongest effect ever recorded by a gamma-ray burst on the planet. A gamma-ray burst is an extremely energetic explosion observed in distant galaxies, believed to be the result of massive stars collapsing into black holes or the collision of neutron stars. GRBs release more energy in a few seconds than the Sun will emit over its entire 10 billion-year lifetime. These bursts can result in the formation of black holes and produce intense jets of gamma rays that can be detected across billions of light-years. GRB 221009A was an extraordinarily powerful gamma-ray burst detected on October 9, 2022, by the Neil Gehrels Swift Observatory and the Fermi Gamma-ray Space Telescope. Originating approximately 1.9 billion years ago in the constellation Sagitta, this burst was detected from a distance of about 2.4 billion light-years away. It lasted for around 10 minutes, but its effects were measurable for over 10 hours, making it one of the longest GRBs ever observed. Despite the vast distance, the burst was so intense that it directly impacted Earth's atmosphere, causing the strongest atmospheric effects ever recorded from a gamma-ray burst. The peak luminosity of GRB 221009A was measured at approximately 2.110 W, an unprecedented level of energy output. This event is considered extremely rare, potentially occurring only once every 10,000 years. Its sheer power and brightness have made it a landmark discovery in the study of gamma-ray bursts, providing valuable insights into the extreme processes in the universe that can generate such colossal explosions.